Alright guys, welcome. First, I would like to give credit to the authors of this material. Credit goes to Jam Remix. Now, we'll tackle theoretical aspects here. There are no much theory questions here, but we'll tackle the ones we could get our hands on. So this chapter 2 is based on linear motion and projectile. Let's dive straight into it. I'm going to be skipping, I'll say skip to every other questions that I would solve separately. So question 1, skip. 2, skip. 3, skip. There's a calculation you need to do for question 3. We'll move to question 4, right? Question 4, okay. The motion of the moving skin of a talking drum can be rightly described as question 4. Let's write motion. Translational motion is also called linear motion. This is a motion in a straight line. So translational motion is also called linear motion and is a motion in a straight line. Next, random motion. Random motion is a motion that follows no regular pattern, or it's an haphazard motion. Number 3, rotational motion. This is a motion that describes a circle. Number 4, oscillatory motion. This is a motion that describes to and fro movement of an object, or this is a motion that is to and fro. To is to, fro is fro, describing vibration, and it is usually called simple harmonic motion. That's oscillatory motion. So I've given translational motion, random motion, rotational motion, the motion that describes a circle, and oscillatory motion, which is also called simple harmonic motion. So number 4, the motion of a moving skin of a talking drum can be rightly described as, number 4 is the oscillatory motion, vibratory motion. Number 5 has to do with calculation, skip. 6, skip. These are cheap calculation questions. I'm going to be treating them, don't worry, and the calculations will be strictly in pidgin. Will be done in pidgin, so it's very easy for you to understand. We'll skip 6, we'll skip 7, we'll skip 8, we'll skip 9, we'll skip 10, 11. Which of the following statement is true of a body which is moving in a straight line with uniform acceleration? Do not forget, whenever a body moves in a straight line, it is translational motion, right? Now, let's tackle this question. What is true here is, right, whenever a body moves in a straight line, it will increase with time in the direction of acceleration. It will increase with time in the direction of acceleration. Option C. And right, this is because there's a constant increase of acceleration over equal time interval, or uniform acceleration. So when a body moves in a straight line with uniform acceleration, what will happen? There will be an increase with time in the direction of acceleration. Option E. 13, 12, skip. 13, the distance traveled by a particle starting from rest is plotted against the square of the time elapsed from the commencement of the motion. The resulting graph is linear. The slope of this graph is a measure of, the slope of the graph would be a measure of half the acceleration. The slope of the graph will be the measure of half the acceleration. 14, which of the following types of motion are oscillatory? Oscillatory motion is a to and fro motion or vibratory motion. Number 14, let's see. A diving board when used by a diver, correct? The motion of a balance wheel of a wristwatch is going to and fro, correct? Number 14 is option A. Number 15, skip. 16, skip. 17, two objects, one having 3 times, skip. has to do with calculation. 17 has to do with calculation. I will need to explain it. 18 calculation. 19 skip. 20 skip. 21. The figure above shows the displacement time graph for 3 different motions. Which of the following statement is correct? 21. Which of the following statement is correct? Graph I, graph 1. Right. The correct answer is graph 1. This graph, look at it, this number 1. This one that is horizontally flat. Graph 1 corresponds to 0 velocity. So 21 is option B. 22 skip. 23. Which of the following graph represent motion with uniform velocity? Option D. It's like the other question we just answered now, option D. Because there's no uniform velocity also means the velocity is constant, so the value is 0, so it's just flat. So whenever you see something like this, it's called uniform velocity. When I'll teach you the calculations, physics is hugely based on interpretation. You need to know how to interpret it. So when they say the thing has a uniform velocity, the graph will start like this, the line will start like this. 24 skip. 25 skip. 26 skip. 7 skip. 28 would need some demonstration skip. 29 skip. 30 skip. 31, 32 skip. 33. A stone thrown vertically upward returns to the ground. Which of the following figures represent the velocity? That's 33. Which of them will represent the velocity? Now, when a journey is upward against gravity, first let's go like this. 33 is option B. When the journey is upward against gravity, so if you throw a stone up, if you want to draw it on the graph, look at it. You see, the journey is upwards against gravity. Now, what happens next? Look at it. It comes from top. You start from up here. Since you throw the stone up, if you want to represent it on the graph, you start drawing from top to down. Then it goes again. So a stone thrown vertically upward returns to the ground. When it's returning to when you throw it upwards, the graph will start from up here to down. Then when it's returning to the ground, the graph will be going up again. Okay, so option B is the correct answer. If you throw it up, the graph comes down. If it's coming down by itself, the graph goes up. The slope of the graph. Number 34. When a ball rolls on a smooth, level ground, the motion of its center is definitely option D, rotational motion, the motion that forms a circle. 35. The velocity time graph of a body moving in a straight line and decreasing uniformly to rest is represented by 35. Look at it. The velocity time graph of a body moving in a straight line is supposed to be horizontally flat like this, but since it's moving in a straight line and it is also decelerating, so you go bring them down. So 35 now, option C. It's cheap. 36, 36, okay. 37. Two bodies projected. Skip. 38 skip. Those ones I would solve them, okay, and you very understandable. These are cheap questions. Cheap skip. 42. The motion of a smoke particle is random motion. Let's not waste time. Option D. 43 skip. 44 skip. 45 skip. Let's see. 46 skip. 47. The diagram above shows a velocity time graph. Do not forget, from F to G it is uniform velocity. The statement is true about the motion. The statement that is true about the motion is that the car does what? From G to this H is decelerate. From E to F it accelerates. From F to G it attains or maintains a constant velocity, and from G to H it decelerates. So E F accelerates, F G constant velocity, G H decelerates. So question 47. Let's see. Question 47. Where are the options? Let me scan through the options of 47. Okay. No, constant. No. Okay. has D here, D has no acceleration between it. F and G, that's it. This F and G, they have no acceleration between them, and that's the answer. So option D has no acceleration between F and G. So number 47 is option D. There's no acceleration between F and G. Otherwise, it could also have been called constant velocity or uniform velocity. Okay. 48. A stone and a feather are dropped from the same height above the ground surface, ignoring air resistance. Which of the following is correct? A lot of students do get this confused. If there's no air resistance, if you drop a nylon or a feather and a big stone, the both of them will fall to the ground at the same time. Okay, so 48 is option A. The stone and the feather will both reach the ground at the same time. They will both reach the ground at the same time. 48 is option A. 49, calculation skip. 50 skip. 51 skip. 52, do not forget, from this place now, like this, is uniform velocity. So they say uniform velocity, then from here, from this point here where the cursor is now, down is deceleration. From the velocity graph shown above, which of the following quantities cannot be determined? If we determine acceleration, okay, yeah, option D. If there was acceleration, the line will go up like this. See as I draw this thing, it will go up like this. But since it starts from here, it means it starts from a uniform velocity. You can't initiate or you can't dictate initial acceleration. 52 is option D. 53, calculating the distance, skip. 54, skip. 55, skip. 56. Which type of motion do the wheels of a car undergo? Which type of motion do the wheels of a car undergo? 56, they undergo rotational motion and translational motion. Look at it, option C. Translational motion and rotational motion. 56, when a car moves, the tires of the car, they perform two motions, translational and rotational. Now we've come back here. Similar question. From the diagram above, the region of zero acceleration will be NS. Option B. How do I know? From this M, notice. Let's go back to the previous question we asked. Remember I said if you are started from here, look at my cursor, and it went up like this, we'll say it accelerates. But this question now, you cannot find acceleration. Acceleration no dey this graph. Now let's go to this other graph that's given to us. From M to N, look at the way it went, this acceleration. From M now, from N to S, this uniform velocity. From S again to P, it accelerates. Then from P to Q, it decelerates. So from the diagram above, the region of zero acceleration is option B. We'll not waste our time there. So we've gotten it, option B. Okay. I actually like to interpret graphs. They're interesting to interpret if you understand it too. 59, sorry. Which of the velocity time graph shows uniform acceleration of the body from rest? 59, now option C. Whenever they draw line like this for physics, go up like this, it's called uniform acceleration. Please, in anything you do, do not mix the class on interpretation of graph. Do not miss that class. In anything you do, do not miss that class. Very helpful. So see the line, the way the line go up like this is called uniform acceleration. 59 is option C. 60 is calculation, skip. 61, skip. 62, skip. 63, skip. 64, skip. I think that's all. Our question stop at 64, right? Yeah, that's all. Skip. Alright, if you've gotten to this point, congrats, you've done extremely well. I gave out some points. There are some things I stated. I would love you to write them down. Now, if you would go beyond the point of smartness, when I was describing each of the graph, you could also draw those graphs down in your notes and also indicate it. The one that goes up, uniform acceleration, uniform velocity, deceleration, and the rest. It will help you a lot when we start the calculation proper. Alright, if you've gotten to this point, once you are done jotting, snap and send to me on the WhatsApp group for assessment. Please note, we run a private session, a private mentorship class. If you'd like to be part of our class, I'll drop the link to the WhatsApp group on the description box. Also, If this is your first time of watching our video, do well to subscribe and also leave a like. It will help YouTube to recommend this video to other students who would also benefit from it. Thanks for watching. I'm Coach Ewan. I'll see you in the next video.